HIV is a blood-borne virus. Mosquitoes are insects that drink human blood to survive. By all accounts of basic logic, every buzzing mosquito should be a flying biohazard. During the height of the HIV epidemic, this exact logical leap caused widespread panic. People were terrified that a single insect bite in the summer heat could lead to a deadly infection. Yet, while sharing a contaminated medical needle carries a very real risk of transmitting the virus, a bite from a mosquito carrying infected blood poses absolutely zero threat. To understand why this terrifying paradox exists, we have to look past the surface of the skin and examine the microscopic architecture of both vessels. Let's start with the hypodermic needle. It's a marvel of human medicine, designed to bypass natural defenses and interact directly with the circulatory system. Nature has its own biological equivalent. The mosquito uses a specialized mouthpart called a proboscis, evolved to puncture skin and extract fluids. Both vessels are perfectly adapted to breach the skin and draw blood. The difference between a deadly vector and a harmless insect comes entirely down to how their internal plumbing handles that fluid. For HIV to spread, one strict biological condition must be met. Infected fluid, like blood or semen, must cross directly into another person's bloodstream or mucous membranes. Imagine both vessels draw in a microscopic droplet of HIV-infected blood. In the syringe, fluid travels up the steel shaft into the empty barrel. In the insect, it travels up the proboscis, emptying directly into the mosquito's midgut. Simply taking the virus in doesn't cause a new infection. The true danger is dictated entirely by what happens to the virus while it waits inside these two very different chambers. A medical syringe is essentially a sterile, lifeless cave. It's a hollow, static void made of plastic and steel. After a needle is used, tiny amounts of blood get left behind, trapped in the microscopic dead space of the hollow tip. Because there are no biological processes, no digestion, and no chemical reactions acting on that residual fluid, the HIV particles survive, floating completely undisturbed. The syringe acts as a microscopic preservation chamber, keeping the virus fully viable and infectious for the next person. The mosquito's midgut is the exact opposite. It is a highly active, hostile biological furnace. The moment blood enters the insect's stomach, the mosquito releases a flood of powerful digestive enzymes. These enzymes rapidly dismantle everything in the fluid, tearing apart the fragile lipid envelope that protects the HIV virus. Without that protective envelope, the virus completely breaks apart. It cannot survive, replicate, or remain infectious inside the insect's digestive tract. A mosquito doesn't store the blood it drinks. It digests it for nourishment, permanently eliminating the virus in the process. Now, let's look at what happens when these two vessels move on and puncture the skin of a second uninfected person. If a contaminated needle is reused, the plunger pushes that preserved, infected residual blood directly into the new patient's circulatory system. A mosquito, however, uses a completely separate biological channel when it bites. It doesn't regurgitate stomach contents. Instead, it injects clear saliva. This saliva contains anticoagulants to keep your blood flowing while it feeds. Since the HIV was already dismantled back in the insect's stomach, it cannot enter the salivary glands. Transmission is physically impossible. When we zoom out from the microscope, the global mathematics back this up perfectly. Trillions of mosquito bites occur worldwide every single year. If insects could act like dirty needles, we would track massive, uncontrollable HIV outbreaks rippling through populations immediately following mosquito season. Instead, decades of rigorous laboratory research and global health tracking point to exactly 0 documented cases of mosquito-borne HIV transmission. By understanding the biology, we can stop worrying about the buzzing in our ears and start focusing on actionable human behavior. Public health efforts need to target the actual vectors of transmission, like unprotected sex and shared medical equipment, rather than harmless insects. Biological literacy is our strongest defense against fear. Share this video to help stop medical misinformation, and let's put this myth to rest for good.